Hi. Thanks for having me here. My name is Dennis Garcia. I'm a system engineer at General Dynamics Mission Systems Canada. I've worked for General Dynamics for over 20 years, mainly on tactical communication systems. I'm here to talk to you about AI in defense. As an emerging area, AI is still relatively new to me, but at the end of the presentation, I am willing to take some questions. If there are questions I can't quite answer at that time, I will take them away and I'll ask ChatGPT later. So our defense forces have subdivided their operational space into 5 high-level domains. That's space, land, sea, air, and cyber. General Dynamics provides capabilities to our Canadian Armed Forces in 4 out of 5 operational domains. GDMS is a trusted partner to the Canadian Armed Forces and has been operating in Canada for over 7 years. Our head office is located in Ottawa, but we do have regional offices in Calgary, where I'm located, in Halifax and Sherbrooke. The general intent of the forces within these domains is to gain an operational advantage over their adversaries, with the goal of successfully conducting their mission. The cyber domain is actually the newest domain out of all 5 of them, being only recognized by NATO back in 2016. A key aspect of cyber is the enablement of data. This includes generation, movement, analysis, and presentation. Cyber allows for more informed decisions to happen by our forces within all of the other 4 domains. A key system within the cyber domain is the C5ISR. C5ISR stands for Command, Control, Communications, Computer, Cyber, Intelligence, Surveillance, and Reconnaissance. These are the integrated digital systems used to gather and process data, enabling commanders to make more informed decisions and maintain situational awareness. The diagram on the left is an operational view. This provides you a big picture view of how the C5ISR interconnects all of the different systems, assets, and people within your operational deployment. The top left-hand corner of that diagram represents your enterprise systems. So this is cloud platforms, big data centers, all interconnected by high capacity, high bandwidth, very stable communication links like fiber. As we move forward into your deployment into the theater and operational spaces, this is where you get into headquarters, deployed headquarters. So these are smaller data centers, cloud, edge cloud type systems. This is where you start utilizing more wireless systems to provide connectivity. These systems are still pretty capable, but smaller and less capable than your typical enterprise systems. And when we start moving towards the tactical edge, this is where your land communication support system for Canadian Armed Forces would sit. So think about deployed headquarters, vehicle portable, vehicle mounted, man-portable type systems. There's little to no infrastructure. Communications relies heavily on low bandwidth wireless bearers like UHF and VHF radios. The diagram on your right is helping to illustrate key characteristics as you move from your enterprise to your tactical edge. The solid line represents mobility. So you can see as you move from enterprise to tactical, your amount of mobility that you should expect greatly increases. With mobility, there's considerations for size, weight, and power, as well as being able to operate in these disruptive, intermittent, and latent environments. So this environment limits the type of equipment and systems that you can deploy. So the dashed line is system capability. And you can see as you move from your enterprise to your tactical side, the amount of compute storage greatly decrease to account for that environment. So these are important considerations when you're trying to apply technology like AI. GDMS enables the C5 ISR with our digital spine, which is a set of hardware and software services that form the deployed network, meeting and optimizing the data needs of the commanders, from the mission network down to the dismounted soldier and everything in between. Here's a little video about that. The defense sector is undergoing a digital transformation, and within the core of the digital transformation is the goal to become more data-driven. The intent is to be better informed when making decisions and taking action. This means more assets like uncrewed vehicles and fixed-wing aircraft like the F-35 that employ more sensors and generate more data throughout your deployment. As more data is produced, systems like the digital spine play a crucial role within the context of becoming data-driven. Digital spine allows for the collection, movement, and presentation of data. But at the end of the day, one of the primary goals of becoming data-driven is the ability to operationalize the information at pace. This is a quote from the D&D and Canadian Armed Forces AI strategy. The sheer volume, diversity, complexity of data produced by modern sensors has already overwhelmed the capacity of human analysts to process and interpret it. This is where AI, generative AI, can play a crucial role in unlocking the value of data. Another quote, in many domains, human intelligence supported by AI can deliver results that are superior to those achieved separately. The goal here is to complement and not replace. Shown here is information pulled from the Defense AI Playbook produced by the UK Defense AI Centre. The organization has identified 6 problem spaces where AI can be applied. Recognize, that's the ability to detect subjects of interest. Standard use case is object recognition. Predict anticipates likely outcomes. A use case here is the ability to predict equipment parts failures. Simulate explores scenarios and outcomes for the purpose of planning. Decide allows for objects like autonomous vehicles to operate. Comprehend drives insights from data, and generate creates new and original content. The last 2 is where you can see LLMs naturally fit. But even with the above spaces, there's a general knowledge that the application of AI is still very narrowly focused, possibly due to the resource limitations in applying this technology within the theater, operational, and tactical domains. Now, with the inclusion of LLMs and generative AI into the mix and taking into account its ability, the application of this technology may be broader, but only time will tell. Now, innovation does not have its challenges. A few related to the application of generative AI within the defense sector, the Gen AI iceberg. We all know that a large portion of the iceberg lies under the water hidden from view. This represents the volumes of data, storage, NVIDIA cards to train and use these systems. If we think back to that operational environment, you can see how challenging it is to deploy a technology like this in its current form outside of the enterprise space. Data classification, data governance is another concern. Data classifications limit the information to personnel with the proper security and clearance and a need to know. Export regulations like ITAR and CGP are placed on this information, also dictating how and to whom information is shared. It's challenging to see how to enforce data governance on a technology that is used to compute, summarize, and disseminate vast amounts of information to only the people with the right to know. And the last topic I'll bring up here is the authority to operate, ATO. ATO is the process of obtaining formal authorization for a system to operate on the CAF's network. It's basically assessing that a piece of technology is operating within a defined risk boundary and that the residual risk is well understood and accepted. The challenge here is that innovation in this area is happening so quickly and it's not well understood. It is difficult to determine the proper regulations to secure and mitigate risks while allowing for innovation to occur. As a partner to defense, GDMS provides scale, speed, and resources for our defense sector in the application of innovative technologies. This includes use case development, addressing concerns like governance and ATO, and the implementation of technologies within a challenging tactical environment. GDMS builds enabling solutions in architectures like the digital spine, creates physical hardware and software products like our MeshNet capabilities that realizes components of the digital spine. And our continued work to incorporate enabling technologies like public cloud, edge cloud, and continue to look forward to incorporating classified cloud. GDMS partners with end users through the relationships we have built over the years, and the programs that we execute, like the LC4ISR support programs, that provides us a direct opportunity to define, build, and implement innovative technologies like AI. GDMS also recognizes the value of Gen AI and is looking to leverage this technology through our own digital transformation initiatives. As a defense contractor, we are also very cautious and must conform to regulations applied to us. Our internal programs like NOMA and Gaia look to cautiously leverage LLMs to extract value from our own data while navigating these waters in a risk-averse way. And of course, GDMS partners with SMBs, academia like UNB, and big industry like AWS and Google. We've created a Battle Lab, which is an incubator for industry to identify use cases and collaborate on solution development. It allows us to experiment, iterate, and innovate at a quicker pace. That's it. I think I'm ahead of time, so